So in this video, I'm going to discuss the boxes problem which occurred in today's CODECHEF challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem is very simple. It is stated that this is the number of test cases, and for every test case there is this thing which is n, and there is an array of size n. Okay. So what you have to do is you can there are some conditions that has been given. Okay. The conditions are that 2 into XOR of all elements of ARR, I mean the array, is greater than equal to OR of all elements of array. Okay, so this is a condition given, and this is a very important condition. Okay, a very important condition. So what you can do is you can choose one element and put it into a box. If the box is initially empty, so you can put the value of that element in that box, and if the box is not empty, you have to check if the XOR of all the elements of the box is greater than equal to that element, then only you can put that into the box and the value of that box becomes XOR of that element. Okay, so that is what basically the problem states. So now from this we can derive one thing. That no matter whatever the XOR is, if you multiply it by twice of it, so it is greater than equal to OR of all elements. And remember one thing, the value of AR of I is of the range 10 to the power 18, right? So if it is of 10 to the power 18, so we know one thing, that we can either use a bitwise thing. Okay, but in this method I will be talking about the greedy approach. So I won't get into the explanation like the derivation of why I am doing this, but simply just remember one thing, that this is the greedy approach, because the explanation for the derivation is very much complex. So what you have to do is you have to find out the largest element of the array and check out the second largest element and then the third largest, that is go by sorting it. Okay, so let's say the array is of like x1, x2, x3 ... xn after sorting. Okay, after sorting, so you have to first of all do one thing. You have to create a box and take xn, then check x of n minus 1. Obviously that will be greater than equal to that, obviously that will be lesser than equal to that x of n. So initially in the box it is x of n, and then you add x of n minus 1, and then you add x of n minus 2. When will you add this? If you find that the XOR of these two elements are greater than equal to this. Okay, so you go on doing that. Once you can't do this anymore, so again you create another box, and then again x of m minus 1, and ... again. So this is a repetitive process. Okay, so let me explain you. So for this 1 and 6, obviously initially in the box you put 6 and you're done with it, so you need one box. For this 1, 2, 3, 12. Okay, so it is already sorted. So we know one thing, that whenever we are talking about greedy, we have to sort it. So it is already sorted. So let's put 12 in the beginning. Is 3 lesser than equal to 12? It is lesser than equal to 12. So over here we write 3, and the XOR of the elements, that is 3 XOR 12 is 11. Okay, so 3 XOR 12 is 11. So initially the XOR of the elements was, before inserting 3, it was 12. Now when we insert 3, it becomes 11. Now we insert 2. Can we insert it? Yes, 11 is greater than equal to 2. So we insert 2. Now what is XOR of 11 and 2? It is 13. Now there is 1. Can we insert it? Yes, because 1 is lesser than equal to 13. So we insert it. And 1 XOR 13 becomes 12. We don't need it anymore because we have completed it. So we can insert all the elements in just one box. For this 6, 5, 4. So if we sort it, it becomes 4, 5, 6, right? So there is a box. So we initially put 6, and the XOR of it is 6. Then we put 5, because 5 is lesser than equal to 6. And once we put 5 in the box, the XOR of 5 and 6 becomes 3. Okay, so it becomes 3. Now there is 4, right? So is 4 lesser than equal to 3? Nope, it is not lesser than equal to 3. So we have to again make another box and insert 4. So this thing we can do in big O of n log n. Why? Because n log n is just to sort the array, and then you have to perform the operation big O n times. Because just see one thing, we are just sorting it and then traversing one by one. So this is what basically my explanation is. So that's it from my side. Thank you.